This is the presentation of our FYP. We are Yimin and Wang Jianling. The topic of our FYP is Exploring Hong Kong by Open Data, Analysis and Processing. Now, I will welcome Yimin to give you a brief introduction of the project.
Web-scale data analysis is a hot topic nowadays. However, where and how to find the web-scale data becomes a challenge. We find that it is a trend for some government and organizations to release the open data. Our project aims to make use of 2011 Hong Kong census data released by Hong Kong government. Our project aims to do the clustering for Hong Kong on 3 layers. They are region, district, and area layers. These 2 maps shows the district and area layers of Hong Kong. Python is chosen as programming language. And for the algorithm, clustering, dimension deduction, and matching, we use the IPython notebook for executing. To visualize the result, we use the Baidu Map API and eCharts for the visualization.
Now I will give you a detailed introduction about the methodology in our FYP. Before we do the clustering, we need to do some pre-processing for the data. We use vector to represent each region, district, and area. But the first question is what we should put into the vector to represent those data points. The first value that we use is the population value. We just put the population into the vector and then use them to represent the region, district, and area. The second one we use is the ratios. We've used 2 kinds of ratio in our project. The first one we use is the number of specific group of people divided by total number of people. And the second one is the ratio between male and female. The reason why we want to use the ratio between male and female is that intuitively we believe that this ratio will be approximately to 1 in a certain region or in a certain district or area, but in reality it's not always the case. So we think that the ratio between male and female can represent some special characteristics of the district or area. And we also use the average value, which we can calculate from our raw data and then put them into the vector to represent the district and area. Well, because there are many different characteristics for each region, district, or area, the vector we get is in really high dimension. Before we do the k-means clustering, we need to define the k. First we want to use the PCA to do the dimension deduction, but we found that the result of PCA is not so good. We cannot see some really obvious clustering pattern from the PCA results. It cannot help us to find out the K for the K-means. Then we find another method to find out our K. Because the purpose of our K-mean clustering is to minimize the cumulative distance in the clustering result. So, in order to find out the k, we try different k's here and then calculate for the corresponding cumulative distance. Cumulative distance in our algorithm means the summary of all distance between each points and the centroid of their clusters. And from this picture, we can see the relationship between k value and their corresponding cumulative distance on the area layer. So we will use k equal to 7 or 8 or 9 on the area layer, and for the district layer, from this picture we can see that we will use k equal to 3 or k equal to 4 when we do clustering on district layer. In our K-mean clustering, we define the center of gravity as the centroid of each cluster. And for the starting point, for example, when we do clustering on the area layer, we will randomly choose k different points from the 412 areas and then treat them as the starting points. When in our project, we found that when we choose different when we choose different starting points, we will get different clustering results. But we want to know how large the influence are, so we design the matching algorithm and stability testing to find out the influence of different k starting points of k-means clustering, and Yimin will talk about these two algorithms detailedly.
Matching algorithm is designed for matching two corresponding clusters for different rounds. The blue one represents the center of gravity of the first round, and the green one represents the second round. In this example, we calculate every 2 points from different rounds, and the nearest the 2 points are, the more similar they are. First, we find the nearest distance is between these 2 points. Then we ignore these 2 points and do the algorithm for the rest of the points. Then we find the second nearest ones are these 2 points, and we do the algorithm till we find all the pairs. After we do the matching algorithm, we can do the stability test. We use two indicators to measure the results. The first one is number of difference, and the second is deviation. Number of difference is designed as the number of pairs which are not exactly the same. The range of this value is from 0 to k. 0 represents the best result and k is the worst. The range of deviation is from 0 to 1. 0 is the best situation and 1 is the worst case.
We've got some clustering results. Here are partial of our results. This one shows one of our clustering result on district layer according to the income distribution. Here the K is 4. It means that we will divide the 18 districts into 4 clusters. We can see that the first cluster include Wan Chai and Central and Western. This may represent the richest part in Hong Kong. And for example, the fourth clusters include Sha Tin, Tai Po, Tsuen Wan, and Islands. This may represent the district in Hong Kong which have lower income. And this is another clustering result, which is on area layer according to the income distribution. We can see that the results in text format will not show you the results really clearly. So we want to use some data visualization tools to do the data visualization and then present you guys the results more clearly. Here, we use the e-chart to plot out the clustering results. The first one is the visualization of the district clustering we just show you in text format. This is the clustering results according to the income level in Hong Kong. And the second one is the district layer clustering on diversity. And the third one is the district layer clustering on all characters. Here, all characters represent the economic characteristics, the educational characteristics, and so on. Which means all the characteristics we can get from our raw data. These three picture are the results we get from the e-charts. And we also use the Baidu map API to plot the clustering result, we put the result onto our website. In addition to those clustering results, we also get some additional discovery in our project. Here, I've mentioned that we have used the average value to represent the characteristics of the areas and districts. So here, I've used the average individual income and average education level to represent each areas, and then I plot out the relationship between these two values and find out that they are in linear relationship. We may use the linear regression method to find out their equation in numerical format. Here, we use the average monthly domestic household income and monthly domestic household rent to represent each area, and then we plot out their relationship and found that they are also in linear relationship. And the positive relationship tells us that the higher the monthly domestic household income will are likely to have higher monthly domestic household rent. And this is the end of our presentation for FYP.